Alright, good morning everyone. Good morning Secretary. So we're gonna continue this topic 13, permutation and combination. As we discussed last week, the first meeting for online lesson, we discussed already exercise 13.1, which is about basic probability. Now we're gonna move to permutation. So what is permutation? Permutation is an arrangement of an object in a definite order. So the order matters. So let's say we want to arrange 3 person. Let's say it's A is Aldith, B Bertrand, C Carlson. So those 3 person are arranged. How many possibilities to arrange them? There are 6. Aldith, Bertrand, Carlson. If we switch Carlson and Bertrand, it's become the second one. Now, if Bertrand sit on the left, it's another possibility. That's how you arrange. If you forgot how to arrange, you can also do this. So if A first, it means it could be A first, B first, or C first. A is after that B and C. Then B is A and C. And then C is A and B. So you could write, after this, expand it again. Okay. So ABC. There's no other possibility. ACB, BAC, BCA, CAB, or CBA. 1, 2, 3, 4, 5, 6. That's 6 possibilities. Now, what if we increase the number of the person that we want to arrange? Let's say there are 8 people that we are gonna arrange. So the answer is gonna be 8 times 7, 6, 5, 4, 3, 2, 1. Why become like that? Let's try if it's 3 person. So it means 3 times 2 times 1 becomes 6. Wow, it works. It's the same answer as that. So depending on the number. Now, how come the formula is basically the number of people and then multiply by 1 less than the number from before? How it's supposed to be like that? So this is the permutation formula. So n factorial, so that exclamation mark called by factorial, and you can use your calculator to find it. So n factorial meaning n times 1 lower than n. So let's say 5 factorial, so 5 times 4, 2 lower than 5, which is 3, 3 lower than 5 is 2, 4 lower than 5 is 1. And there you go, just find the answer. What is 0 factorial? Try it using calculator. You can use your calculator to answer factorial, just find where is the button. Now, let's go to discuss an example. Start with example 3. So, find the total number of different permutations of all letters of the word smart. How many words are there? There are 5. So just 5 factorial. There you go. 120 is the answer. Now, 9 books, 9 different books. So just 9 factorial. These are the answer. If there's the 10th book, so becoming 10 in total, so 10 factorial. That's the answer. Just like that. Now, permutation of are objects from n different objects. So what does it mean? So let's see the example. For a school concert, 6 items are proposed, but only 4 chosen items will be put up at the concert. So how do we choose 4 out of 6? So we make a box, 4 boxes like that. And then what do we do after we make 4 boxes? Now, the first box is the first possibilities. How many possibilities how many possibilities of items to be put in the first box? It's 6 because simply no item have been taken. So if we already put 6, let's say item number 1 is already picked. So we cannot put item number 1 again in this second box. So the next should be 1 lower than the previous. So on until all the box already filled up. Multiply all the answer, then becoming 360. That's how to solve it. There is a formula for probability to solve that. We just do 6p4. Simply write 6p4 in your calculator, then you get the same answer as 360. What does it mean by that? So basically, this permutation formula is this. NPR is basically n factorial. So the n is the number on the left, which is coming first. Divide by n minus r, open bracket, close bracket, factorial. So if it's 6p4, it means 6 factorial on top, and then 6 minus 4, close bracket, factorial. So 6 factorial divided by 2 factorial. That's how you find it. The same thing. Then how to answer this? Your calculator will tell you. How do we simplify this? Look at here. Technically 2 and 1 is cancelled, so 6 times 5 times 4 times 3. It's the same thing as the box method. Now, this is the formula in general. You can take notes about this. Formula for permutation. Okay? Now, if you already tried, 0 factorial is actually 1. Okay? Now let's move on to the other example. Find 5 letters permutation that can be formed from letters word Singapore. Singapore has 9 letters, so just pick 9. Pick 9. Pick 5 out of 9. The answer is this. Now, a club has 4 officials: president, vice, secretary, and treasurer. If a member cannot hold more than one office, in how many ways can the official be selected? If the club has 12 members, just 12 P4 for this, then you get the answer 16 P4, then you got that. Next, permutation with restriction. What does it mean by that? So restrictions meaning there is requirements that we need to follow, such as what? Let's see. So calculate how many 5 different 5-digit numbers can we form from these numbers. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 digits that we can use, and we have to select 8 from 5. And then the requirements are less than 40,000. So how do we solve that? If you think that you don't understand, you better repeat or just rewind 10 seconds. Okay? Now, so we are trying to choose 5 from 8 different numbers. But remember, the requirements is less than 40,000. So the first digit cannot be 5, 6, 7, 8, and 9. Because if it's 5, then it's gonna be 5,000. sorry. If it's 5, it's gonna be 50,000. Okay, and 4 also cannot because it's gonna be 40,000 something. So the only possibilities is number 1 and number 3. Okay, now let's say number 1 is already chosen. So the next possibilities is any number basically, but we cannot put 1 anymore. So just 3, 4, 5, 6, 7, 8, 9. How many numbers are there? 7. Let's say number 3 is already chosen. 6. Again, minus 1, 5. Again, minus 1, 4. Multiply everything, then you can get the answer. Or we can simplify this part. This is basically similar to the one before, which is selecting selecting 4 numbers out of 7. So just 2 times 7 P4. Because selecting 4 numbers out of 4, selecting 4 numbers out of 7. 7 P4. There you go, you can get the answer. Now, the requirements is even number. So how do we classify a number if it's even or not? Remember, even numbers, we only care with the last digit. So the possibility for the last digit, it's only even number, which is 4, 6, and 8. That's why there are 3 possibilities. Now, what number that we can put here is the same thing. Any number can be put. So how many numbers left if I already pick 1? Let's say we already picked this number, so it's gonna be 7 numbers left. We choose 4 out of 7. So 3 multiplied by 7 P4. Just put the number, put the answer from the calculator. Let's see. See? 3 times 7 P4. Now, the next example is about permutation all letters in the world history. Okay? Now, if letter O and letter R are together, so technically if it's O and R together, they gonna be in one elements. Okay? They're gonna be counted as one elements. So how many letters in words history? 1, 2, 3, 4, 5, 6, 7. 7 letters. So we need to arrange that 7 letter, and that 7 factorial is gonna be 5040. But since O and R together, we gather them together to form one block. It means one unity. Within this block, 2 letters can be permuted into factorial ways. Why? What does it mean by that? So technically, we can write OR or RO. There are 2 different possibilities if we want to arrange those 2 words only. But what if we add with the letter H, I, S, T, and Y? So what do we do is basically, since this O and R becoming one unity, so the total is not 7 factorial anymore, it's becoming 6 now because decreased by 1. 6 multiplied by how many ways to arrange words O and R? 2 factorial. So it's the same with this. Now let's move on. Letter O and R are not together. Nah, these things are the opposite probability. So technically, something that yes, probability of something happening positively plus the opposite, then the total should be the whole thing. Probability to combine the whole thing. So we know what's the whole thing. Probability of the whole thing is 5040. That's why we just need to subtract this by something. This is not together, so probability if they are together, which is 1440. So we just need to subtract, because probability of together, which is this, plus the probability which is not together, which is that, it's becoming the probability of basically arranging the permutation without any restriction. Okay, Now, 4 boys, 5 girls forming a line. The first 2 are girls, okay? So, what to do? So technically, how many people are there? In total, there are 9 at all of them. And there are this amount of ways to arrange. But the first and the first 2 are girls. So, how many possibilities to get girls, to arrange girls? 5. Then the second one, since 1 girl already chosen, and it's 4. Now, we just need to find the other 7. Now, we just need to continue. So, 5 times 4. And then, since there are 7 other people that we want to select without any restriction, so just 5 times 4 times 7 factorial. It's gonna be the same as below here. Okay, now the next question. The first a boy and the last is a girl. So same, first a girl, there are 4 girls, and the last is a boy. And what to do on the middle? So just 4 times 5 times 7 factorial, the way I'm arranging 7 different people. Now, the next question, C. The boys are together. If together, we need to count for 1 unity. So technically, 4 boys, 5 girls. Okay. If the boys are together, so this 4, how many ways to arrange this boys? 4 factorial. Now, the boys are combined into 1, so they becoming 1. And then how many girls are there? There are 5. So we total them and find how many possibilities to arrange these 6 people, which is 6 factorial multiplied by 4 factorial. The same as the answer right here. Now, the last question is about no 2 girls stand next to each other. So, what does it mean? If no 2 girls are together, the position of 5 girls relative to the 4 boys must be like this. So the girls cannot be next to each other with the other girls. So it must be girl, boy, boy. So take turn like that. Okay. So how many ways to permute the girl? It's 5. The boy, 4. Just multiply them. Okay. Because this could be girl 1, or this could be girl 2, or girl 3, or girl 4, or girl 5. So there are 5 possibilities for this only. Next, this is 4, this is 3, this is 2, this is 1. That's why it's 5 factorial. Okay. Now, it's time to do exercise 13.2. Okay. Try to do question 1 up to question 8. Okay. I mean question 9. Okay. Next meeting, we're gonna continue the question. Okay. But for today, just 1 until 9. Okay. So thank you and good luck.